Now last time we talked about arcs and how they relate to the circumference of a circle. Today we're going to be talking about sectors and how they relate to the area of a circle. Let's start by talking about area. So the area of a circle is pi times the square of the radius. So area is pi r squared. That's the formula to find the area of a circle. Now if you're given the diameter, you will have to divide the diameter by 2 to get the radius before squaring it and multiplying by pi. Take a look at example 1. So here you're asked to find the area, and the radius given to you is 2.5 centimeters. So the area is pi r squared, so this would be pi times 2.5 squared, which is 6.25 times pi, which comes out to be about 19.63. So the area of this circle is about 19.63 square centimeters. Let's look at the next one. Here instead you're trying to find the diameter, and you're given the area of this circle. So we'll use the same formula, but this time, instead of trying to solve for the area, we're going to substitute for the area and then solve for the radius, r. Now note that we won't be completely done when we do this because this is asking us to find the diameter. So this is 113.1 equals pi r squared, and we're trying to get r by itself. So I'm going to divide both sides by pi. Now dividing by pi and then taking the square root of both sides, this gives us that the radius is about 6 inches. Now don't forget this is asking us to find the diameter, so we have to multiply the radius by 2. So the diameter is going to be about 12 centimeters. Now what are sectors and how do they relate to area? A sector of a circle is the region that's bounded by 2 radii of the circle and their intercepted arc. So here's an example. This portion here that is shaded in yellow, that would be a sector of the circle. Now, how do you find the area of this sector? And how does it relate to the area of the entire circle? Now, similar to arcs and the circumference, we can write a proportion in order to determine the area of a sector. So the ratio of the area of a sector of the circle to the area of the whole circle, which is pi r squared, is equal to the ratio of the measure of the intercepted arc to 360 degrees. In other words, the area of sector APB over pi r squared is equal to the measure of arc AB over 360 degrees. The area of the shaded region over the area of the entire circle is the same as the ratio of the measure of the arc AB to the entire circle, 360 degrees. Now, if you're solving for the area of the sector, you could multiply both sides by pi r squared, and you would have that the area of the sector is equal to the measure of the arc over 360 degrees times pi r squared. So you're really finding the fractional portion of the circle and multiplying it by the area of the entire circle, which is pi r squared. Let's take a look at example 2. Find the areas of the sectors formed by angle UTV. So we're going to start by finding the measures of both the minor and the major arcs. Now, since the measure of angle UTV is given to us as 70 degrees, we know that the measure of arc UV is 70 degrees, and then to find the measure of the major arc USV, we would do 360 minus 70, which is equal to 290 degrees. So we know that the arc UV is 70 degrees and arc USV is equal to 290 degrees. Now that we found those measures, now we can tackle finding the areas of both sectors. So the area of the smaller sector, the red portion there, that's going to be the measure of arc UV, which is 70 degrees, over 360 degrees, and then we're going to multiply it by pi r squared, so pi times 8 squared. This comes out to be about 39.1. Now to find the area of the larger sector, the part that is shaded in blue, we can do the same thing, but now the measure of the arc would be the measure of arc USV, over 360 times pi r squared. So that's going to be 290 over 360 times pi times 8 squared, which is equal to about 161.97. Now you should notice that when you do add the sectors together, because they form that entire circle, that this should equal the measure of the area of the entire circle. So pi times 8 squared should be the same as 39.1 plus the 161.97. All right, take a look at example 3. Use the diagram to find the indicated measure. So first, we're asked to find the area of circle D. Now, since the area of a circle is pi r squared, we will simply substitute for r, which is given to us as 14. So this is pi times 14 squared, which is equal to 196 times pi, which comes out to be about 615.75 square feet. Now part 2, we're trying to find the area of the red sector. Now we see here that the red sector here, the measure of arc EF is given to us as 120 degrees. So to find the area of the red sector, we would do 120 over 360 and multiply it by the area of the circle, which we just found, 615.75. That comes out to be about 205.25 square feet. All right, now to find the area of the blue sector, we are going to do something very similar to the last part, except that now, instead of finding the measure of arc EF, we want to know what the measure of arc EGF is, the measure of the major arc. That would be 360 minus the 120, which is 240 degrees. So the area here is going to be 240 over 360 times the area of the circle, which is 615.75. And that comes out to be about 410.5 square feet. Let's look at example 4. Use the area of a sector theorem. So use the diagram that's given to find the area of circle V. So in this case, this is a little bit different because we are given the area of the sector, and we're trying to find the area of the entire circle. We'll stick with using the same formula, but we'll just be substituting in different things. So the area of sector TVU is equal to the measure of arc TU over 360 degrees times the area of circle V. So the area of sector TVU is given to us as 35. The measure of arc TU is given to us as 40, and that leaves us with the area of circle V. Now multiplying both sides by 360 and dividing by 40, that gives us 315. So the area of the entire circle is 315 square meters. All right, let's look at example 5. Find the area of circle H. We see here that we're given the area of the sector. We're trying to find the area of the entire circle. So again, we'll use that same formula, but we'll substitute in different things. So the area of the sector is given to us as 214.37. And pi r squared, we don't know what the radius is. And pi r squared is in fact the area of the entire circle. So that's actually what we're solving for. Now the measure of arc FG is 85. So this will be 85 over 360 degrees. Now cross multiplying and solving for pi r squared, which is the area, will come out to be 907.92. So the area of the entire circle is 907.92. We don't need to solve for the radius here. We're being asked to find the area of the circle, so we're all set with this problem. Okay, we have one last example. A rectangular wall has an entrance cut into it. You want to paint the wall. To the nearest square foot, what is the area of the region you need to paint? Okay, so the area that you need to paint is the area of the entire rectangle, the entire wall, minus the area of that entrance. Now, what is the shape of that entrance? We can see we have both a square and a semicircle. So let's write that out first. So the area of the wall is equal to the area of the rectangle minus the area of the semicircle and the area of the square. Now let's calculate each of these. So the area of the rectangle would be 36 times 26. And then the area of the semicircle, this is where we are applying what we learned today. So this would be 180 degrees, because that's a semicircle, over 360 degrees times pi times, in this case the radius is 8, squared. And then we add on the area of the square, and that would be 16 times 16, or 16 squared. So this ends up being 936 minus, and then in brackets here, 32 pi plus 256. So subtracting all of that, we end up getting about 579.47. So the area is about 579 square feet.